Alright, this is GCO7. This video deals with worksheet number 1 and is very similar to the concepts that we just did in the previous objective GCO6. In GCO6 we were referring to the congruence of any shape or any figure, and here now we're narrowing it down to only that about triangles. So you'll see this definition is very similar to the last one, but now more specific to triangles. So two triangles are congruent when one triangle can be mapped onto another triangle using one or more isometric transformations. So again, this is the same thing, except instead of the word figure or shape here, we've narrowed it down to just be triangles. So again, two triangles are congruent if I can map one onto the other one. And again, this is a congruent statement dealing with triangles, and it's corresponding, meaning that it tells us who matches who in the triangle. So angle A matches up with angle D, angle B matches up with angle E, angle C matches up with angle F, sides ABC match up to DE, sides BC match up to EF, and finally CA matches up with FD. Okay? Now these, all of these basically are a function of the fact that we know that the triangles are congruent, so this is all true. These are known as the corresponding parts of congruent triangles are congruent. It's kind of a long thing, but basically it says the corresponding parts of the congruent triangles have to be congruent. Now let's just take a quick look at some examples of congruence. Because this is a reflection over the x-axis, the coordinates here match up, so we know it's they have to be congruent because I can reflect one onto the other. And if I wanted to just do a quick test, of course, to establish that that is true, I could reflect this onto the other, and sure enough, I established that they are congruent based on a reflection. Over here we see a similar kind of an argument that says these two triangles must be congruent because there is a translation that maps one onto the other. So it says if you slide 1, 2, 3 to the right and 5 down, you would land on the other. And again, the definition of what it means to be congruent is that I can map one triangle onto another. Let's just do that very experience here twice. The first one says, can you map ABC, this blue one, onto DFE over here, or DEF, using a reflection and then a translation. Now my thought is if I reflected it down here, it would not look very good to be able to translate it. So I'm actually going to reflect first on the y-axis, and that will land me in these positions, and you can see now that that's a very nice position to be in. The setup works nicely, and then the final step, of course, is a translation that goes straight down. The x stays the same, and we want to go down 6 spaces. And that would land A onto D, B onto E, and C onto F. Now just maybe to review something we did earlier notation-wise, this would be a reflection on the y-axis. of triangle ABC, followed by a translation of 0 and negative 6. Again, notice the order: first, second. One last one. We notice here they want us to start with ABC. It's the green one, and we want to go over to this pink one. And we're also going to do a reflection and then a translation. And I think I'm going to want to reflect on the x-axis. And here's why. I notice that if in its current position, if I reflect on the x-axis, it would of course flip and be in this position, and now it would slide nicely into its spot. So we're going to do that. Reflect first. Which would place it right here. And then we will take that and we will translate it. Now, let's see. So we're at 2 here, so we're going to go left 11 and keep everything else the same. And A would jump on to T, B would jump on to G, and C on to H. Once again, just by way of review, what we did is we reflected over the x-axis, triangle ABC, and then we translated negative 11, 0, establishing that this is congruent to this because we could map using isometric transformations.